says a 1,000 kilogram empty cart is moving with a speed of 6 meters per second. Is about to collide with a stationary loaded cart having a total mass of 5,000 kilograms as shown. After the collision, the carts lock and move together. So, calculate the speed of the combined carts after the collision. So, after the collision. So, this sounds as momentum. Sounds like a momentum problem. So yeah, because we have mass, we have speed. So momentum is mass times speed. So we could find the momentum, and then we could divide the mass, and then we get speed on its own, which is what they want. So first, alright, let's do the givens. They give us, alright, so this is cart A. We're gonna refer to this as cart A, and this one is cart B. So cart A tells us it has 1,000 kilograms as the mass. This is cart A, and it has velocity of 6 meters per second. Okay, cart B, 5,000 kilograms, 0 meters per second. This cart B, 5,000 kilograms, 0 meters per second. So, this is the equation. Momentum equals mass times velocity. So we're gonna do them individually first. So P equals. So this is for cart A first. 1,000 kg times 6. So this is 6,000 kg meters per second. Okay, that's cart A. Cart A. And alright, that's the resolution. Now cart B. Let me write the equation again. P equals mv. Fill it in. Cart B had a mass of 5,000 kilograms, right? It says right there, cart B, 5,000 kilograms. And a speed of 0. So, yeah, that'll be 0. So, whatever. Potential energy for B, P is 0 kilogram meter per second. So, alright. So, they say that the carts lock. Right here says, the carts lock and move together after the collision. So these masses, they're gonna add up. So they want us to find the velocity of when it's locked up. So it's 5,000 plus 1,000. 6,000 kilograms. And okay, that's the given. Let's do givens now. Givens. 6,000 kilograms. That's the mass. We just did potential energy. So this one had, car A had 6,000 kilogram meter per second potential energy. This one has 0. So yeah, you combine them. There are two potential energies because in a closed system, the potential energy is always the same. So yeah, we could use the same potential energy again because it's never going to change in a closed system. So P equals 6,000 kilogram meter per second. Now the equation, we're going to use the same one. P equals mv. So 6,000 kilogram meters per second, that's P, potential energy, equals M is 6,000 kg times velocity. So we just divide by 6,000. So this will just be one, what is that? 1 meter per second. Equals V. Okay. That's the answer for 66. So let me read that up here. 66. 1 meter per second. 67. 68. 67. Calculate the kinetic energy of the combined carts after the collision. So here's the formula for kinetic energy. Half mass times velocity squared. So they want it after the cards combine. So we just established that that the mass is 6,000, because separately they're 5,000 and 1,000. You put them together, that's 6,000. So do that again. Given this is a G, M equals 6,000 kg. What else do they need? They need the velocity. We just found the velocity is 1. So where is it? Over here. Velocity 1 meter per second. So equation is Ke equals half mv squared. Ke equals half mv squared. Now let's fill in. M 6,000, velocity 1 meter per second square. So okay, half of 6,000 is 3,000. Kilograms times 1. Okay, meter per second squared. Okay, let me do this. Let me show it down here. Meter per second squared is the same as doing it like this. So you multiply fraction, you multiply across. So meter squared over second squared. That's the new. Those are the new units. So 1 meter squared per second squared, and that's the kinetic energy. Ke equals 3,000 kilograms. Meter square per second square, which is the same as a joule, J. So we could just write 3,000 J. So that's the answer for 67. 67, right? It was 3,000 joules. Okay. Now 68. How does the kinetic energy of the combined cards after the collision? How does the combined energy of the cards after the collision compare to the kinetic energy of the cards before? So the kinetic energy, let's see. The kinetic energy before the collision. Alright, we'll have to do the kinetic energy for each individually. So alright, so the formula is Ke equals half mv squared. So for card 1, let's figure it out for card 1. A. So alright, we know the equation. Let's just fill it in. We also know the givens. They were up here. So the equation is Ke equals half mv squared. Ke equals half m. The mass for card A is 1,000 kilograms. Velocity 6 meters per second. Meters per second. Now Ke, okay, half of 1,000 is 500 kg times 6 is Ke. Oh, squared. This is squared. So this is 36. Because 6 times 6 is 36. And as I did over here with the units, it turns out to be meters squared per second squared. So 36 times 500 is 18,000. 2,000. Let me do it on the calculator. 500 times 36. Okay, 18,000. 18,000 kilogram meter per second. both squared, and as I said, this is the same as a joule. So 1800 J. That's called A. Now this is called B. Called B. Alright. Same formula. KE equals half M. So the M for card B is 5,000. Velocity was 0. 0. Okay, so the kinetic energy for this is 0. Alright, so whatever you do, KE equals 0 joules. So 0 plus 18,000 is 18,000 joules. So that's before. Before equals 18,000 joules. Now after. Did we do after? Yeah. Kinetic energy of the. Alright, so after was 67. We did the kinetic energy for after they collide. So 67, 3,000 joules. So yeah, after they collide, there's more kinetic energy than before. So that's the answer. So after collision, I'll just write it short. More kinetic energy. Alright? So now let's see the answers. What number? 66. 2, okay. 1 meter per second. 67 was 3,000 joules. 3,000. And 68 is kinetic energy before is greater than after. How? Oh yeah. I made a mistake. This says 18,000, not 1,800. I thought it said 1,800. So the kinetic energy before is greater than after. So this is backwards. Before a collision, more kinetic energy, right? Alright, remember all this math, so yep, that's 68.